Okay, so this is going to be your density notes. So the first thing that we're going to talk about here is mass. What is mass? Weight. Be careful.
Particles.
There's people in the world that will get really mad at you if you try to tell them that mass and weight are the same thing.
Particles in your body.
Particles. How do we measure mass? Grams. That's maybe the most important thing for now.
So mass is just grams.
What if we want to measure a lot of mass? What unit of measure do we use?
Megagrams.
We could use megagrams. I'm going to talk about kilograms. Right?
Yeah.
What if we want to measure a really small mass?
Centigrams.
We could measure centigrams. Milligrams is usually the one that we use. Centigram is okay too, but milligram is one.
Wait, doesn't your weight change if you're in Mars?
Yes, that's why mass and weight are different. Is because mass is technically not dependent on gravity. But the reality is that you can never measure mass without gravity. So maybe it's a moot point. All right. The other thing we're going to talk about is volume. How do we measure volume?
Length times width times height.
That's true. What unit of measure?
Milliliters.
Milliliters. That would be a little amount of
Cubic.
liters, right?
That's not me.
If it's a lot of liters, then it would be a...
Kilo.
I'm going to write the word killi. This is really hard to spell, by the way. Kiloliters. Isn't that the silliest word you ever saw?
Yeah.
I don't know if I've ever heard anybody talk about kiloliters. Doesn't that just mess with your brain? Okay, or we could have milliliters. We definitely use that a lot. Milliliters. That one messes with your brain too, but not quite as bad. Okay. The important thing here is that both of these types of things are what we call extensive properties of matter. Okay? And what this means is that the measurement changes with the sample size. If you have a big object, what kind of mass do you have? Big. If you have a small object, what kind of mass do you have?
Small.
Small. If you take a big object and you cut it in half, you make its sample size get smaller. What happens to its mass?
Smaller.
It gets smaller. In fact, it gets smaller by half, right? If you cut it in half. Right?
Yeah.
Okay? So that's what it means to have an extensive property. Okay? However, we're going to now try something new. We are going to divide them. We're going to divide them. Who's got a mass of an object? Look at your data page for a second and give me a mass of an object.
We just do
18.73.
18 point what?
73
73. And that's what unit of measure?
grams.
Grams. And what was that object's volume?
0.9 milliliters.
0.9 milliliters. That must be like styrofoam or something.
Right.
No, that's not styrofoam. Okay. So there we go. Can you stick that in your calculator and divide it?
Yeah.
I'm trying to think what. I think you've got some whacked out measurement. I don't think I have anything that dense.
Okay.
Maybe we missed.
But we can still do it as an experiment, right?
Yeah.
Okay. 18.73 divided by 0.9. Well, the densest thing on Earth is 22 point something. So
Yeah, styrofoam's up there.
no, I don't know why I was thinking styrofoam. I don't know why I said that.
Wait,
I'm
22
done.
points something million?
Yeah, the densest thing is 22, and this is 20. I think it's the element iridium. All right, here we go.
What? I don't know how I index.
20.81. Hey, now tell me, look up here. Did I cancel out any units of measure when I did that?
No.
No, so they're both still there. Okay. All right, are you ready? So now, let's suppose that we had another thing. Okay? And this other thing, let's just say, I'm going to make up a number here. Okay? Let's suppose the other thing weighs 9 point, I don't know, 6? Sure. 9.6 what? Yeah, but I want another digit here. 4. Okay? And it has a volume of 0.5 milliliters. All right? What? Hi. We do have a spill. It's right over here.
For this big machine or just
You probably just want a mop.
okay. Let's see if
I'm sorry if I was not clear about that in the.
it's.
It was just a glass of water.
Translated down. I don't know what it is.
Sure, it's just a glass of water. Okay. So what's this one? What's that one come up to be? Stick that in your calculator. I know he was ready to like mop up the whole pool, wasn't he? 9.64
He's still there.
divided by 0.5. Are you guys paying attention? What do we get?
19.28.
Once again, did I cancel out any units of measure?
No.
No. So where are they?
On the right.
Dividing
still
each other
there.
side. Wait, so is that the answer?
That's the answer.
Okay.
All right, so here's a question for you here. Do you notice that they're like almost the same?
Yeah.
Like they're not perfect, but they're like, considering that we like almost made those numbers up off the top of our head, that's pretty close, right?
Yeah.
Do you think it always works that way?
No.
No, of course not.
Of course
Did I kind of like help you make up those numbers off the top of your head? I kind of helped a little bit because I kind of wanted it to come out that way because I wanted to point out that these two samples
not.
right here. There we go. Kayvon, watch your feet. These two samples have very nearly the same do you see it?
Density.
Right? Same density. And what is density?
The amount of.
I gave you this a minute ago. Oops, sorry, it's off the screen. You see this right here? Do you realize that when we divided these two things, we came up with almost the same answer? Thank you. So this is called an intensive property. Okay? And in this one, the measurement is constant. No matter what. Think.
size.
The size. I'm going to write sample size. Do you see that? So, in your lab, can you look back and do some division problems there and find some objects that are the same material? And therefore, even when you do the division, they come up with the same numerical answer there because they're the same material. They have the same density. Can you try it?
Yeah.
Try it.